It's good to go, baby.
Okay.
Yep.
Well, folks, how you doing? My name is Bob Lauer, and I'm here in beautiful downtown Penns Grove High School, and I'm here to try to simplify some things for you. I know that, we go to meetings and we hear all about the funding issues and money and mortgages and things like that, but it's very complicated for me. But as a math teacher, I just kind of like to simplify it a little. So if you'll bear with me, I think I can pretty clearly explain what's going on in our world. Now, first of all, you have to look at the fact that we've got a physical presence. We've got a church, so mathematically, that looks like a church. If we inscribe that, let's say, into an ellipse, just for example, and we have a major axis of B and a minor axis of A, then what you're going to end up with is an equation for an ellipse. And that's okay. This kind of helps us a little bit understand the layout of the church, but that's not enough because we have economic implications, we have problems with recession, we have everything. And so if you take a look at this and apply Ramsey's theory to it, you can really describe it with a summation. So I'll try to do that, letting our variable go from 1 to n. So if we take a look at this, you can see what happens. You've got it described here, but that's not enough because, listen, we know that nothing's for sure, right? There are uncertainties. So we have to consider the uncertainty principle. Whenever you consider the uncertainty principle, you've got to consider probability. So, look, make sure that our combinatorials are in the right place and we can apply probability to this issue. Now, this isn't enough either because, look, money costs money, right? And the longer it takes you to spend it, the more money it's going to take. So we've got to consider the time value of money. Are you with me? You've got to consider the time value of money. Well, the time value of money depends on a lot of things. It depends on the interest rate. Depends on how many times you compound the money, right? So if you add that to the equation, you can see that now we're getting somewhere, right? I think I can say, without worry of being contradicted, that what happens here is that you end up with, I guess the best way to describe it would be a Möbius function. Okay? In a Möbius function, if I use 1 over n as the variable and describe it like this, now you're in good shape because now you've got the economic implications, you've got the financial implications. This will lead us to another summation, which really is a Riemann. It's a Riemann formula. I mean, you knew that. But it's a Riemann formula that I can describe like this. Now, we've done almost everything, except look, there's issues involved with where the church is, how big the grounds are. It all costs more money. So we have to add the double integral. We have to integrate over the regions that the church is sitting in. And if we do that, making sure that we are doing this with respect to time, because time obviously is our variable here, we end up with the absolute value of another Möbius function. So, look, it's intuitively obvious where we are from here. But that's not what we're about. What we're about is, what can we do to shorten this process? Well, what we do is we take a forcing function. We'll call that forcing function J of D. Now, some people can call that a Joash drop. Mathematically, that's a little imprecise, but we'll call it Joash drop. When you filter everything we've done at this point through this Joash drop forcing function, what do you think we get? It's intuitively obvious. Casual observer knows. It's 5. 5-digit mortgage.